Hi, my warmest greeting from the International Union of Architects. I'm Tan Pei Ing, the UIA Secretary General, and it is my great honor to be given this opportunity to address all of you. On behalf of the UIA, I would like to welcome you to the second UIA webinar organized by the Public Health Group. The last UIA General Assembly at the end of July 2021 has mandated 2022 as the UIA Year of Design for Health. The mandates include the use of UIA resources to launch an open access digital information hub on designing for improved health, benefiting all nations, to establish an international research agenda to advance the goals of designing for health, and to support the creation of resources that will help architects conduct research in designing for health. As such, this is one of the key focus of the activities of the UIA this year. The UIA Year of Design for Health 2022 highlights the importance and impact of design in every project in promoting and sustaining health of the community, not only confined to healthcare facilities. The principles of design for health shall therefore form part of our design DNA and be integrated in the design and planning of all types of development. In addition to the logo competition and the launch and roundtable forum that was held at the beginning of 2022, as part of the UIA concerted efforts and initiatives to promote design for health, the UIA Public Health Group has planned a series of 4 additional webinars with the aim to empower architects' design process with appropriate research methods for better outcomes so as to protect health, designs that develop better health, and design that restores health. The first webinar on planning and design of healthy cities, urban public spaces, and parks was successfully conducted on the 25th of April. This second webinar will be dedicated on the health facilities planning and design. Healthcare facilities or healthcare architecture is a very specialized field that requires comprehensive research and design to promote and restore health. The architecture typology for healthcare services demands precision in its planning and requires close collaboration with multidisciplinary stakeholders, including input from not only the professionals such as medical planner, architects, engineers, healthcare management consultants, but also the patients, caregivers, and other users. Research and evidence-based designs have proven to be effective tools in bringing forth innovative and new approaches to designing health facilities. The recent COVID-19 crisis has not only put pressure on the existing healthcare facilities worldwide, it also highlighted the importance of collaborative, responsive, and creative ways for the architects and other stakeholders, including the public, to work together in a manner to bring technology, research, and design to deliver values. There's a great need and urgency for us to transform and rethink on how healthcare facilities are to be designed that's more progressive, adaptable, and sustainable. Now I have the pleasure and honor to introduce the moderator of today's event. Professor Dr. R. Chandrashekhar is a member of the Public Health Group from India and the chairman of the IGBC Green Healthcare Rating. He has a very impressive profile, and he's a member of the faculty at multiple institutions, including London South Bank University, All India Institute of Medical Science, and the Institute of Health Management Research, Delhi. Dr. Chandra is the first PhD holder in medical architecture in India and participated in building design and engineering approach to airborne infection control with the Harvard School of Public Health. Some of his notable achievements include receiving the first humanitarian award for outstanding contribution to the people of India for his work in improving the state of the art of architecture for health in India. Now, I'd like to invite Professor Dr. Chandrashekhar to take over.
Thank you, Pei, for wonderful introduction. And in fact, greetings from India as well as International Union of Architects Public Health Group. And as Pei has already mentioned and clarified, this is the Health Facility Design and Planning webinar, the second of its series. And the Public Health Group in International Union of Architects has already decided the year 2022 being the year of design for health. Yes, we do agree and recognize that the post-pandemic has given more importance to particularly healthcare infrastructure. And right now, like as I am also looking after a few of the things in the sustainability and parameters, evidence-based design, etc. in our country, and these are the need of the hour. The connect with nature is going to be the main issue. So today in this seminar, we have 4 wonderful speakers and also giving from the different part of the globe. We have a speaker from Germany, speaker from Switzerland, speaker from Canada, and also speaker from Ghana. Now this varied interest and varied culture, varied habits and different climatic condition, how these experts are handling various projects at their area. So today I would like to invite our first speaker, which is architect Christoph Gatermann. He is the managing director in the healthcare division of Niki Architect in Germany. He has been a member of the AKG since 2016 and an associate member of UIA Public Health Group since 2007. Gatermann completed his studies at the Technical University at Aachen and ETH Zurich in 2004. While studying, he focused on healthcare facility planning and developed a deep understanding of the specialization early on. Since completing his study, he has focused on in-depth inventory analysis and target planning for the structural optimization of the reconstruction of hospitals. He has been involved in a large number of hospital projects at all levels of care and is mainly responsible for them in the general planning role. So I invite architect Christopher to make his presentation and enlighten us.
Well, first of all, thank you very much, Professor Chandrashekhar, for a very nice and kind introduction, and all the people involved in organizing this webinar. I'm very pleased to being able to join the group today and to giving some impressions and some advice on target planning from Germany. So regarding future healthcare needs, we always try to consider what would be the perfect hospital for each and every country or for the local demands we have. So this is what we have focused on in the office for the latest 20 years, and we see an ongoing change is happening right now. So what I'd like to start with is an aerial view of the city of Berlin. This is almost this is the capital of Germany, and this is almost the city core. What you can see right in the middle is the very impactful for the medical development in Europe is the University campus of Charité. So what you can see there is the existing and recently remodeled high-rise building which is War Tower, but all these ancient or these elder buildings where quite some impactful research has been developed for the last 150, 200 years or even longer. So very important and famous researchers have been working here. So this is an urban situation. It is a very densely populated city of Berlin, and this is still a very impactful campus, though it is suffering from some structural layout. But what you can see here, we can see buildings from each and every decade or a century, and still they need an update on and ongoing. So healthcare design is an ongoing process, and what is valid today might be less impactful for the next decade. So let's try and see what this is all coming from and what we are currently thinking would be the best fit for the future. So briefly, this is a historic overview. So for the last 3 to 4 centuries, you can see that healthcare facilities more have been a very small focused facilities where care and wards have been centralized. And then they have been some pavilion structure trying to separate gender, trying to separate different infectious diseases as far as people knew way back in that time. And then there has been a first campus layout to be made in several pavilions because there was deeper knowledge in infection prevention and so on. And what you can see then in the 20th century, this is the academic medical center of the city of Aachen, which is in the very western part of Germany, close to the Dutch and French border, which is almost a machine-like looking building, which is highly efficient. It is very good in wayfinding, but it's some kind of far beyond what the people's or patient needs are. So currently we're talking about healing architecture and the patient focus and the staffing focus healthcare design. So this is currently what drives the mind to the future. So just to let's skip some slides due to the time available, but just as a brief historic overview, so we can see very extendable and expandable structures for the last 2 or 3 centuries. So strategy of how to develop this was a large number of multi-patient rooms to be organized in a linear structure. And what you can see, ward is about 80%. And examination and treatment way back at that time wasn't very taking a lot of space. So for the last century, this has been increasing number of examination and treatment rooms, which you all know. So these are these ancient typologies. You see this is still patient focused, all the patients in large corridors or hallways. And this is the way and the structures how this development. Karin, you might know this. This is a very unique layout from Christoph Gatermann, who are in the healthcare business as well. And so the unique thing about this, they have been looking at these ancient structures, and this is more like an annual figure. And what they said, okay, is this the wayfinding and all the pathways around take a lot of way. And so they took these and they condensed these and pushed all the 4 staircases and elevator shafts to the middle to be more efficient and shorter in ways. But what is very unique, you have a beautiful shell and surface and the outlook to the country around. So this is another example of a hospital which our office is just recently developing in Switzerland and close to Basel, which has a similar approach. All the ward rooms on the exterior facades, and you have short ways to all the service rooms and the shell and the core for the elevators and so on. So how did the healthcare typologies develop? So in the 1960s, you had all these slabs. This is highly rational and this is highly efficient, where you have a socket of 2 or 3 stories with all these functional departments, ORs, ICUs, X-ray, and so on. And then in this huge slab, all these wards. And you know that all these slabs are highly, depending on the property available, this is highly efficient, but it's a very fixed thing. So you cannot determine how many people or patients you can put on the 13th floor and the 7th floor. So it is highly, it is not very flexible, but this is very fixed and it takes a lot of internal traffic time. So we identified that these is at least valid for Germany or Central Europe, that these slabs are very difficult to run when it comes to running costs and for staffing as well. So then later on in the 1970s, there's this, what I could say or name is, this is more a brutal structure. It looks a little like from the petrochemic industry coming, but this is actually the hospital of Aachen. Some of you might travel to Germany have even visited this. This carries about, has about 1,400 beds for wards still available, but it is highly cost inefficient. So they're currently thinking of, after just 40 years, 50 years, they took into consideration of in replacing the entire size. So the average time for lasting time for a hospital of this size is about 30 to 40 years. So if you compare this to the running and the building costs, it is not very efficient. So what would it be the future hospital layout would look like? Was it even smaller and having 2 of them, or was it the opposite direction, having 2 urban suburban hospitals to be consolidated and have one bigger facility downtown or close to a major city. So there's different strategies. So you can see a large clinic in Munich, which is also suffering from the slab related things. So even though way in the back 70s, this was considered a milestone, this is pure functionalism and radically short distances, but it's very rigid. So actually, where is all this going on? If you see a floor plan like this, and you see that the main entrance hall is here on the very bottom right, and you have to go and walk all the way, this is like an airport. It's even the longer distance than an airport, and we are all traveling a lot, so we know what this is. If we go back and forth and pushing beds back and forth to go to an X-ray department or emergency here and going back to the ward down here to the left, it takes a lot of time to going there, and it takes a lot of staff to operate this. So as you all know, especially in Central Europe, running costs are covered by public insurances and private insurances, and staffing has become an increasing problem. So we have an elderly or a growing number of elderly people, and I'll come to this. You see a couple of different or similar structures. So you see there's always a main corridor, entrance hall, and then this is like this is a very rigid structure where you have all these departments which are detached to the north and south of these main corridors. So this is what we call like a spine layout. So we have a core spine, or even in the other one, you can see this is a major spine crossing the entire structure, and you have everything which is a second spine and all the departments being in between. So, but this is a rather horizontal structure, and as I said, this is not very efficient in wayfinding, and almost call it traveling time there. So this is the end of this kind of spine structure. We consider we have to combine what we found more efficient from the former centuries, compact style, and combined with a clear layout. So what is definitely driving or currently driving or challenging our populations? You can see this is the aging pyramid from 2015, just 7 years ago. So you see staffing, this is in the age of almost 20 up to 60, 65, the age where most typically people retire. So this is the largest part of the population. If you shift that or project that 15 or 20 years later, this huge amount of people has been just entering the retirement age, and they would be becoming increasingly becoming patient or these chronic impatients, and we have some kind of bottleneck situation. So staffing and the younger generation being able for the labor market, so staffing is definitely the current and the future challenges. More people to be taken care of by less people available for the healthcare market and the care market. So we have to have building structures which are most way effective, and so that less people can treat more people. So functional areas are growing, nursing areas are concentrated, and what we recently, this is I think the major driver of this decade and the future decade, is home care replaced by IT devices, mobile devices. So nursing and wards, the number of beds in patient capacity will decrease. The number of function and the capacity of functional areas will dramatically increase, outpatient departments and what have you. So this is, if you compare this to this Hamburg thing, where this huge slab carrying all these wards for all the inpatient, we wouldn't have these capacities anymore in the future. So we need to find more efficient structures for the future. So this is a university hospital in Hamburg. You can see this is a master plan from 19th century. This is how it actually was built. So this is totally without order. And the latest master plan from about 10 years ago was trying to get this thing in order and being more compact and density and having more outpatient department and less ward units. So this is what this looks in the major focus. And this is, you can see there's connected wards where you can shift patients back and forth, where you have short walking distances for staffing and for waste and supply and goods, and short ways to all the examination and treatments areas. So this is more dense and more focused on outpatient and examination and treatment rooms. Second part, this is a cardiovascular center just across the street. So this is currently under construction, and this has a different layout. So when this has this core and spine, this is the spine where all the elevators and shafts and where all the organization is detached to. This other smaller building has just a central elevator, and then you have some kind of radial distribution of patients and good and very, very short ways for staffing. So less people can take care of more people and be more functional medical process efficient. So this is what this basically looks like. This is much smaller scale because this is focused on cardiovascular diseases as well. And this is another driver which we can currently state, that you don't have the general hospitals, but you have smaller focused hospitals as well on this academic medical campus. Another example from Vienna, which follows the same strategy, centralized and then a radial distribution and organization of all the functional and ward departments. So this is, again, this is connected, but very short walking distances. So in Switzerland, currently under construction, is going to be completed by the end of 2024. It goes under operation. Similar approach. You have the wards on top. And what is most important is that you have highly flexibility and not separate ward units, but this is just large scale wards with only several sections across the corridors. And you have some kind of what we call floating areas. So if you have abdominal surgery here and you have spine surgery here, and so you can shift patients back and forth, whatever capacity is needed. So, and we have the central core of accessibility. This is what it basically looks like. Give you an idea, central courtyard and where you go in all directions. Recently, design competition, which we delivered 2 years ago, centralized court, and this is more a modular design. So this is definitely what we consider is very valid for the future, and is going to drive future healthcare planning as a modular design. Modular design meaning one neutral core in the middle where all the elevators and shafts are going, and you have spaces for people to meet and bars and whatever, and then having several ward units, always 3 ward units being interconnected for shifting patients back and forth as the capacity is needed. And you have a socket where all the examination and treatment is just located, which you can see here. And what is most important, I just put on your notes here, radial accessibility, you have annular connectivity, and what we consider most important, you have a sandwich level for mechanical floor and densification, and expandability. So this is the entrance floor where you have all the examination and treatment, and this has to be an open way structure that you can expand this capacity as we learn more outpatient, less inpatient, less wards. Can linearly expand all these capacities, and you have a neutral corridors here. This is doctors, this is internal patients, this is outpatient, and this can grow. So you need space and linear layout.
I have to wind up fast.
Yes. So what are the planning criteria for the future? We have to have a topological openness, modular basic structure, as you just can see on these pictograms, and a clear measurement order, which is always challenging when public money is involved. So everyone's trying to cut on costs. But I think this is another example here. I think having a clear module, currently we say 7.8 meters. Currently in Switzerland, we are more than 8 meters construction grid, which is a perfect fit for OR rooms, for examination treatment rooms and wards. So this is what we are currently struggling with public authorities. but hospitals are growing and growing. So finally, just final layout. You can see again, this is a very clear layout. This is a core spine. This is outpatient. This is inpatient, and this is all decentralized thing where you can go upwards to the wards. And what we expect, which is the final statement, what we expect, I think wards, inpatient wards, will in the future carry more severe, not injured people, but severely, or these severe chronic illnesses and diseases, and patients will stay shorter, but will receive much more care, not by number, not by scale, but by intensity. And outpatient departments will grow. So let's be flexible in this structure. So these are the final statements: linear, expandable, modular, which can be, each and every module can be adaptable and changeable. It has to be connected, and of course, it has to be attractive, not only as a healing environment for a patient, but also for winning future staff. So let's close with this picture. I think this is an operation for about 12 years now. It's still valid. It's still very efficient, and it has the ability to being adapted and changed for each and every cluster for the next 2 or 3 decades. I think this is what we definitely can consider most important: being adaptable, exchangeable, and interconnectable.
Thank you.
So thank you for your attention so far. So I'm very looking forward for your questions.
Thank you, Christoph. Very elaborative, nice presentation. In fact, you gave a very good historic overview of right from 1819 to 1960s, 70s, 90s, 2010, and what next. And also elaborately mentioned about your spine layout or comparative age pyramid. Age pyramid is very important point which you raised, and it is a cause of concern everywhere, not only in Germany. It has become a big issue. And geriatric care growing, and still we have lesser staff taking care of more patients. It's a very cause of concern. And also covering the radial typology, linear, modular, how you concluded with the sectional and attractive like healing environment, etc. Wonderful. Thank you very much. Now I'll request our second presenter, this architect Karin Imoberdorf. She is a partner and member of the board of Lead Consultant Incorporated and Swiss representative of UIA Public Health Group. And she holds a master's degree in architecture, worked for 10 years as project manager and member of the board of Bern, responsible for the section of healthcare building at Little Brekebu Architects. Maybe I know whether I pronounced it correctly. Her interest in architecture for health, people, and sustainability was clear early on after writing her thesis on the Central Hospital of Zug extension and reconstruction with a focus on sustainability and spatial qualities. Her work includes strategic consultancy, master planning, performance modeling, process analysis, operational analysis, and operational concept, programming, and medical technology equipment. Kevin, now floor is yours. You can make your presentation.
Thank you very much, Dr. Chandrashekhar. It's always difficult with names from other countries. I'm also struggling. So thank you for introducing me. I will speak about master planning within boundaries, and my focus is also hospital sites, of course. So the goal of a good master plan is to give a framework for future developments. It must be flexible and adaptable enough to allow change. You have already heard about that in the previous presentation. And on the other side, it must be rigid and strong enough to guarantee a good long-term usage of the available area. Thirdly, it must add quality, human scale, nature, and daylight. I will now explain my view and experience on master planning, playing with boundaries on all levels. Many of you most, I guess, have already encountered this situation. It is a question of setting the priorities right. The institution seizing the occasion of the wheel first will have a big advantage. Three elements dominate hospital planning today: quality, quantity, cost. This is simple. The more you build, the more it costs. And if you do not lower the quality. And if you want to rise quality, you'll have to lower it somewhere else, redimension the project, or find money. The advantage of master planning is that introducing quality, and you've already done that with your introduction, green is costly, but very important for the health of the people working there and getting healthier in these buildings. So that might be done on an early level of strategic planning, where cost is not as much in the focus yet, not that precise. So this is the moment to introduce the wheel. However, there are more challenges to come, and even the best master planner will not be able to forecast the influence competition, conflicts, catastrophes, and pandemics have on building sites of the future. The master plan has therefore to include a certain souplesse, as you say in French, softness to react, as I would translate it. I believe that the big advantage in being human is that we can learn from our ancestors in the same time as we try to apply new techniques and findings. Let us just jump back a little in time. Not far back, just 100 years. I will not travel as far as you have done, Christoph. So at that time, a hospital stay often lasted at least 10 times longer than today. In Bern, a pavillionary structure was the answer to their needs. And I think the old Bernese structure is an interesting solution, erected without boundaries, in green fields outside of the city center. This postcard does not represent the original, very clear master plan Grützmatte, as it was called, from 1880. However, it still shows the clear structure with the main administration building, the pharmacy building, and the kitchen in the center, serving the functional clusters conceived to serve their specialities. So all these pavilions around it. The buildings were low-tech, of course, at that time, in special position due to their use. Therefore, the building here for infectious disease and the children's hospital. Still, this disposition made it easy to be changed. On this slide, you can see how Bern looked before the Inselspital was built in 1880, so this is 1865. The site chosen for the new hospital was well connected and located outside of this medieval structure of Bern. 50 years later, the pavillionary structure was in place and running, but parallel to the city's evolution, introducing infrastructural elements as the motorway here, connecting here to the city center, and also the railway, which allowed the city to grow. The site was transformed, and bit by bit, buildings were exchanged through big functional clusters. This led to a rather difficult situation, and the authorities decided that a new master plan had to be established. The winning proposal introduced simple but effective rules. At first, the application of an old peasant rule shall allow constant replacement and renewal. The translucent blocks you can see on the model to the right represent a set of fields, allowing new hospital structures to be planted, as a peasant would say, or in builder's term, constructed step by step. These fields or building plots have clear outlines and defined maximum volumes. However, within this definition, you are, as a planner, free to conceive your building, to need it, to shape it according to your vision of its future usage. Secondly, a clear separation of flows is the long-term vision. The actual main access road marked in orange here on the plan, linking to the main street, linking to the motorway and the city center, will remain in use, but it will be used only by cars and public, or mostly by cars and public transportation. A new central boulevard is introduced for pedestrians. On the plan, it is marked in pink, and it crosses the area from east to west and leads to almost all public entrances. If accepted by the public, this boulevard will be fed with users by an underground station. A revolution for Bern, I can tell you. It would be central, based here. Lorries and other logistic vehicles reach the area from the north. Actually, they have the access road in between the hospital side and the churchyard, but thoughts go even further here. In the long term, the major part of logistics shall enter through a tunnel connecting, it will go under the churchyard and connect to the existing industrial area of Bern. This would reduce the amount of heavy traffic on the site and open up for new opportunities to use the different building plots. Thirdly, the introduction of green areas will prevent the site from being overused. The big lorry park here in the south and the pocket paths in between these building blocks offer welcome recreation areas. These areas shall also serve for interaction. This might foster innovation and strengthen the university's hospital renommé. The parks all contain historical buildings of value, giving the site roots, memories from what has already been reached, and a sort of patina. The public was introduced and included in the process through different organs and finally approved the master plan. You can see the final document here with very high acceptance. An important step. The framework was set. I'd now like to show you whether this framework works. The plan looks simple and clear, doesn't it? However, looking under the big gray building blocks, you can see these fine lines, and these are the existing and functioning buildings, which are to be replaced step by step. The first and yet biggest step was to replace today's main building of the campus. Studies had shown that refurbishment or partly reuse of the structure was not possible since the concrete structure from the 70s was too strict, floor heights insufficient, and changes in the high-rise structure extremely costly. So another competition took place for building plot 12, the Anna Seiler House. The new Center for Cardiac Disease is planned for open heart surgery. And I'd say that's true for what is functional later on in there, but also building-wise, it is an open heart surgery. Being part of the winning team as hospital planner, we established the rules for the connections in between the buildings. Not only building plot 12, this building here in the center on this very simple sketch is to be interconnected, but all buildings have to have independent liaisons in between each other so that they can work and be replaced with this system. So you can see here the separation of flows, logistics in green, ambulatory patients and visitors in blue, then interventions and operational processes in red, and stationary transfers of patients in bed, and also a good link for staff is marked in yellow. It looks very simple on this scheme, but in reality, it's far more complicated. The building itself has a clear layering, close to patient entrances on 2 levels, ambulatory services and diagnostics. Still in the base, however, above, the operational theatres and cardiac catheterian laboratories with intensive care units are placed. All levels highly installed with floor heights of 4.5 meters. In the towers, care units are located, and in between, marked in blue, technical floors, serving in both directions, and of course, from the top down and bottom up as well. To add another dimension of flexibility, 2 levels with offices are set in between those 2 zones, here marked in green. And they are able to get transformed easily into more patient-focused usage if needed. This flexibility is reached through a simple bidimensional grid structure of 8.4 times 8.4 meter, and vertical elements, very concentrated ones, are located concentrated like tree stems. Generous light shafts follow the tower structure down to the bottom floors, bring light and orientation. We applied, well, here a picture of the open heart surgery building-wise. And we applied, of course, lean construction methods and BIM methodology to plan the building in this huge team of planners and users. However, numerous live meetings and user talks help to define our standard rooms, mock-ups, and medico-technical equipment. This practical example shows the importance of the new master plan, the clear framework and yet flexibility. By today, 3 other plots are in further development. Plot 4 for logistics, plot 6 for a new medical center, and plot 7 for laboratories. So let me zoom out again. A master plan has to answer today's needs within today's society. The hospital is part of a smart city and must be smart in itself. Cities grow. Good health care services should be close. Hospitals must be great places to work in. Thousands of employees enter their doors daily and should stay healthy. They must be appeasing environments like a monastery to answer patients' basic needs of calm and recreation. And however, we expect hospitals to have efficient structures, including the highest technology. Learning from our ancestors, the Inselspital in Bern is a good example of the peasant three-field economy. Overexploitation not only there leads to a collapse. Wise planning includes sufficient space to reconstruct. Master planning implicates knowledge on flows. They have, on bigger sites, to be clearly separated. How are patients to access a site, the building, a room? How all the other users? Of course, the room does not come first with the master plan. Still, standardization with adaptation is helpful. Modularity gives you freedom for planning. Last but not least, we have to understand the implications future developments within research, technology, connectivity might have on our buildings. There never is only one right answer. There are different sets of wheels you can choose from. One for the winter, one for the summer, one with spikes and one for races, or just one for universal use. Think carefully, choose wisely. Thank you very much.
Thank you, Karin. What a wonderful way of explaining the master planning strategies. And really, I appreciate your, putting up quality, quantity, and cost, and the drivers and factors, and explaining the case of Bern. And in fact, I am very impressed with your statement, master plan leads to open heart surgery. You know, this is some, you can interpret it in a different way. All architects can think of it. It's a very, very strong statement. And a clear framework and flexibility, green and smart hospital. We are all talking about how we have to do. And one more thing also I liked it was the scheme looks simpler, but complicated in reality. It is not that easy. You know, sometimes we draw the plans and we think that it is, but in practical, it is a little different. Now we are moving on to our third speaker, and is architect Tye Farrow. Is a senior partner at Farrow Partner Architect based in Canada. He gained a bachelor's degree in architecture from the University of Toronto and a master's architecture in urban design from Harvard University. Farrow specializes in the intersection of architecture and neuroscience and is a world-recognized pioneer in this field. This is great achievement. He is the first Canadian architect to have earned a Master of Neuroscience applied to architecture from the University of Venice, IUAV. He has worked on numerous award-winning projects, and Farrow has been described as a global leader, making a significant contribution to health and humanity through the medium of architecture at the Stockholm World Design and Health Congress. Tye Farrow, now it's your baby. Please carry on.
Thank you. Can you see my screen?
Yeah, perfectly fine.
So what I would like to explore is how we can construct health within our health facilities. And importantly, what actually causes, instills health. This is in the context of the pandemic, the COVID pandemic, and the various waves that we've been moving through. But most importantly, the hangover that we're experiencing now that has a significant impact on mental health and mental illness, not only on our communities, but also the people that are working in the hospitals. So the question is, what if we were dedicated and focused solely on creating buildings that actively instilled and caused health? What if we were focused on environments that were health-giving to the people that use these important institutions within our communities? And what happens if we would no longer design or tolerate hospital facilities that cause dis-ease? I'm using that word specifically, boredom and depression as a result of the environment. There's one thing that's very clear is there is no such thing as neutral space. What we create either has the ability to be health-giving or in fact do the exact opposite to erode our ability to flourish. And that's both ecological, physical, emotional, and as it relates to economic health. There's a lot of discussion about high performance buildings around the systems of healthcare buildings, but what about human performance as a relationship to the environments that are created? And can we intentionally tune the environments in such a way that we can enhance human performance, both the people that are working and healing in these environments, effectively creating these high performance, human performance buildings that, as a result of the design, stimulate learning and memory, enhance healing, but also enhance our social relationships, person to person, staff to staff, staff to patients as a result of it. And in effect, as a baseline, with the goal of activating optimal health. I'd like to just step back a minute and look at the relationship between neuroscience and space. And Donald Herb in the late 1950s began to observe that mice, that lab mice were taken out of their cages and put in appropriately stimulating environments. In fact, they lived longer, they had less behavioral issues, and the tests that they were asked to do, they solved them significantly better than the caged animals. This went on into the University of California, Berkeley in the 60s, where they found the mice in the stimulating environment, in fact, grew the synapses between the neurons in the mind, at an astonishing rate compared to the caged animals, which is clearly very important for the health and functioning of the mind. And in fact, the research found the exact opposite. These little mice that were in impoverished environments, in fact, it began to impair the development of the brain. This was shown significantly in a major case that went to the Supreme Court in the United States. Robert King, part of the Angola 3, spent just shy of 30 years in solitary confinement without a window and was out of this space for 1 hour a day. And it showed that it damaged the hippocampus, which is a very important part of the brain at the bottom of the brain that's responsible for spatial orientation, navigation, and effectively the brain, because of the environment, wilted like a plant. So the question is, what is the relationship of this to the places where we live, where we learn, where we work, and importantly, where we heal? Why is this relevant to what and how we build? Well, we know that design has a significant impact on ecological health. We also know design has a significant impact on societal health, and that has manifested itself clearly through the pandemic. And we know that design, how we design, has a significant impact on our physical and our body health, and this sort of tsunami of chronic diseases that are rolling across our healthcare society significantly. The design profession has responded in a big way with all of these certifications and challenge and building standards and guidelines. But arguably, these things are becoming a standard of care, but equally, they're more focused on the hardware of the body compared to the operating system. Now, that's a bit of a simplification, but really beginning to focus on the relationship of what we create and our mind health. There's the emerging interest in the intersection of neuroscience and architecture around the globe. And this focus on creating enriched environments. And enriched environments have the ability to understand our cognitive and precognitive reaction to the environments of which we inhabit. And as a result of those reactions, they have psychological and physiological impacts on our human health. And so drilling down into that a little further, that this neuroregeneration begins to occur in our brains throughout our lives. And this is where neurons are formed and grow, which have the responsibility and the overlay of our ability to learn and adapt as a result of the impacts of the spaces we inhabit. And positively stimulating enriched environments do a number of things. They reduce stress, anxiety, decrease blood pressure, but importantly, enhance our ability to learn, our memory, and strengthen these neural networks. And so we need to shift to begin to think of space as a therapeutic treatment, a non-invasive therapeutic treatment that enhances our neurons and reduces neuron degeneration. The analogy in many ways is architecture is like food. We consume the spaces around us, and they have the ability to enhance our mind, our body, and our spiritual health. Or in fact, they have the ability to do the exact opposite. A lot of the environments we inhabit give us and are full of empty calories that have significant impact on on chronic diseases. You know, I show this picture and I say, you know, what do you see on the screen? And you say, well, it's a hamburger. And in fact, what it is a symbol of a lot of the environments we create. They're very transactional. They're very good at doing exactly what they're asked. You look at the hamburger, very functional. You don't need a plate, a knife, and a fork. You can hold it in your hand. It gives you protein, but arguably it leaves you feeling empty after an hour after you've consumed it. And in fact, it will do more bad to your health because of the sodium and other things. Is this a picture of the type of healthcare environments that we create as an analogy? Are we creating these environments that are packed full of mineral and vitamins that enhance the health of the people, both body and mind health of the people that are working and healing within the environment? And in fact, can we infuse these spaces with architectural super vitamins? And so I want to just touch briefly, and we don't have the time to get into it, but if we look at the neuroscience and the architecture evidence and research, our mind constructs enriching relationships, person to place, person to our environment, in a very similar way that we construct in our mind's eye person to person relationships. So if you dig down into the psychotherapeutic impact studies, The qualities of enriching person-to-person relationships have two primary factors: that we feel emotionally safe, understood, and accepted, and importantly, the sense of coherence, activating our own resources. If we translate this into personal place relationships and the qualities of enriched environments that we can infuse and create, the qualities are as follows: environments that give you more than they're asked for, they're generous, and reach to a higher aspiration. Secondly, venues where you feel engaged and stimulated, environments that begin to radiate abundance, youthfulness, and life, that are optimistic. We know a lot about the role of nature, but that's not just biophilic elements, but it's natural shapes, natural light and materials, but importantly, these mid-range dimensional complex fractal patterns, variety and vitality, places that radiate this interest and the ability for seeking curiosity and positive ambiguity, authenticity, places that are real, rooted in the place. And importantly now with COVID, this idea of solidness, silence, an unplugged architecture that allows us to listen to ourselves. If we begin to translate this into healthcare environments, and I'll just show you a couple examples of that, generosity and legacy, again, an important one, surroundings that communicate more than they are asked for and communicate this higher purpose. This is a major medical center in the heart of Jerusalem. You can see the overall site. We were hired to master plan it, so the existing building with the outline of the site. We won't get into the specific pieces, but there's a north campus, a middle campus, and a southern campus. But, which wasn't in the program, what was instilled was a major urban park to serve the surrounding people in this neighborhood. So again, wasn't programmed, but it emerged as well as a major set of urban outside areas, not only for the people that are working and healing there, but also the surrounding community. Sense of occurrence, places where you feel engaged and stimulated, and that's not only the people in the hospital, but also the surrounding community. This is in Dublin, Ireland, that we're involved with. Mater Private is really the flagship hospital in the country for a variety of signature programs. The existing building, we won't get into the planning detail, but a whole bunch of vertical additions, horizontal and new builds, as well as major renovation. But the chief of staff, when we started the master plan, said, you know, we are the flagship and we are a cathedral of medicine within the entire country, but we feel like we're a little parish church when you approach it. And so the idea was to begin to create this architecture that not only engaged the hospital and the hospital community, but the surrounding areas, so that on a rainy Dublin day that you would walk down the street and you would be protected and embraced with these tree-like structures as you began to enter or not the hospital itself. Then optimism, again, a very important thing in healing environments that radiate this abundance and life and youthfulness. This is the first phase of the Jerusalem campus. This is affectionately known as the butterfly. It's the largest timber structure in the region that begins to try and communicate a very specific message of abundance, youthfulness to the people that are using the facility. A construction photograph. There's a whole number of terrace gardens throughout the building from top to bottom. So a picture of the rendering on the left with one of the gardens, and then on the right, the construction shop. The garden hasn't arrived yet. But what it's trying to do is create a very specific message to the people that are healing here, as well as the people that are working and visiting, about what the values of the organization is and this path of journey that people are moving through on the metamorphoses, like the butterfly, through their cancer journey itself. Nature, we know a lot and hear a lot about biophilia, not only nature, but natural shapes, materials, and light, and these mid-range fractal patterns. This is a hospital in Canada with a variety of renovations and additions we've been involved in. But when you walk in the front door of the hospital, the appearance is like a tree-lined garden. And there is not only natural light and natural trees, natural materials and the natural forms that are beginning to speak to the mission of the organization. Riding vitality, this seeking and curiosity that when you walk in, instead of these very long straight corridors, about 100,000 square meter new greenfield hospital. But when you walk in, instead of the straight corridors, these curved corridors that aren't confusing, but allow you to understand on where you're going and moving. And that's down to the same thing with the stairs on changing your perspective as you move up and down. Authenticity, environments that are real and rooted. This is on the west coast of Canada for an Indigenous community inspired by these religious bent boxes they create. And so again, when you walk into the front door of the hospital, the artwork was conceived, built by artists in the community, assembled by children. And lastly, the final thing, the silent stillness. These are these pop-up COVID hospitals that have started, that were in arenas. We know that little babies shouldn't be in dark environments. They need to see the daylight and the daylight cycle, but we're putting patients as well as staff in these environments. And this is a small high-performance COVID facility we're involved with to address staff burnout. So this is the COVID ICU area. The main feature, as you can see, it's a very tight, dense plan, but with these clear story windows. I won't get into the planning, but in the center is the staff areas. To the right is staff support, surrounded by the COVID bedrooms. But this feature of this pop-up clear story, importantly, while you're lying in your bed, you're coming to your consciousness instead of the window beside you, it's straight ahead so that you can look out. And the whole driver is for the patients as well as the staff to begin to understand when it's turning into the evening towards the nighttime, the changing light and seasons as well as daylight, to use the architecture as an accelerant for health. And so the idea is that we can use environments, enriched environments, as this medical treatment, non-invasive, that can enhance physiological and psychological health, which stimulates learning, our memory from a neurological standpoint, as this non-invasive therapeutic treatment as the basis of architecture. Why should we do this? For one reason, to create the conditions which we can flourish. If you're interested, there's a book that's coming out that we're publishing, coming out in the fall, that's looking at this from a neurological and perspective. But some thoughts to share to the discussion. Thank you.
Thank you, Tye. It was a real different aspect, actually, what you touched about the human performance of building, and particularly health footprint of a pandemic. Post-pandemic, there are a lot of impact. And also mentioned, when we as an architect talk about spatial planning, he said nothing like neutral space, and try to emphasize and enhance social relationship besides healing. These were few very strong, statements. So I would like to tell our participants who are already listening to our speaker, you can post your question in your question box, because our now is going to be the last speaker. So we can take up the question and you can mention the question is related to the which speaker, so that they will be able to answer you. So you can post your questions in the question box. So now our final speaker is Fiifi Sam-Awortwi, is a certified architect of the Ghana Institute of Architects and principal architect of his firm Vital Space Limited based in Accra, Ghana. He is also on the board of the Ghana Green Building Council and a physical facilities inspector for the Ghana Tertiary Education Commission. He has worked on numerous residential, industrial, and commercial commissions. Many of these notable schemes are in the health sector. The firm's most recent work is the concept design and planning scheme of Wakanda City of Return by the African Diaspora Development Institute, ADD. Looking to the future, Fiifi seeks to embrace more socially impactful projects in line with the maxim adding meaning and value to the built environment. Fiifi, your sustainable design and architecture, your specialty. Please go ahead with your presentation.
Yes. Hello. Can you see my screen?
Yeah, very much.
Okay. Right. So thank you, moderator, for the beautiful introduction. Just a minute. Yes. Thank you for the beautiful introduction. I bring you greetings from Ghana, West Africa, and I'm honored to make this presentation to this August body. I will be presenting on the subject, an emergency approach to the design and construction of the Ghana Infectious Disease Centre in the time of the COVID-19 pandemic, on which I was a deputy project manager for the design team, as well as deputy project manager for the construction team. This presentation is based on my personal experience and research while undertaking the project, designed and constructed within 3 months. So I will be presenting highlights of the rapid process of events, research, design process, working teams, construction process, lessons learned as we continuously strive to create safer and healthier environments. The project was private sector led and was initiated by a philanthropist with a team of industry leaders through an SPV called COVID-19 Private Sector Fund. In the atmosphere of patriotism and volunteerism, the Ghana Institute of Architects offered its services as its corporate social responsibility and rallied allied professionals in the built environment to participate. So we had the Ghana Institute of Architects, Ghana Institution of Engineers, Ghana Institution of Surveyors, Ghana Institute of Planners, and the Engineers Regiment of the Ghana Armed Forces. We were also supported by the University of Ghana, Noguchi Center for Medical Research, governmental health agencies, we had the media partners, and a contractor who worked with heavily discounted rates and dared to let his workers go onto the site in the heat of the pandemic. The efforts of all who contributed are much appreciated. So we had a very simple brief as follows: quick creation of a space for containment, and the temporal structures were up for consideration. We also had to minimize the risk of infection to health workers, which was on the rise at the time. We had to also put up a dignifying place for the sick. So our project approach was a two-pronged strategy. We likely constituted two teams, the design delivery team and the construction delivery team, and we were to work concurrently. As you can see in the construction delivery team, it's almost entirely composed of the Army. This was in order to exert the discipline and consistency needed to complete the project on time. Of course, this approach had its own challenges, but in the heat of the moment, this was our best option. On our screen now is the rest of the core project team from the built environment professionals, from accountants to medical personnel and our fellow built environment groups. So research had a big role to play in this project, despite its emergency nature. Many reference materials were sought, and what came up readily illustrated and simplified for use was guidelines for COVID-19 quarantine and treatment centers in the Ethiopian context. And this was produced by the Association of Ethiopian Architects. This document is in conformity to the World Health organization SARI training manual, from which it had a number of references. At the time, the country was in lockdown, so a lot of professionals were working from home. And this was the time this document was shared on the African Union of Architects WhatsApp page. And this allowed us time to peruse it prior to the engagements and get acquainted to it. So it largely covered the following areas: nature of the COVID-19 virus, review of existing local and international standards, case studies on COVID-19 quarantine and treatment centers, and then most importantly to us, spatial and engineering requirements and recommendations for the physical structure for COVID-19 structures. So this project is situated in Kwabenya, a suburb of Accra, and on the premises of Ga East Municipal Hospital, which had been commissioned a few months before and was in its defense liability period. It also had been designated for isolation and treatment of COVID-19 in the South. It had existing medical facilities like kitchen, laundry, etc. to support our IDC. The medical staff here too had already been trained to handle COVID-19 cases. Right, so now we'll move to from the literature to the architecture, what our research brought us. The facility mostly deals with healthy people and infected people. And these are the two main categories that we need to zone our spaces to suit. And also to create defined circulation paths so we don't get people infected easily infecting the uninfected. So as you can see on our screen, we have healthy people, we have infected people. So the healthy people must move to the infected people to take care of them and then return as healthy people, not infected. With that, you would have to go to a process of decontamination through that zone. But then before you go into the infected area, you'd also have to put on the appropriate PPEs. The green area represents the medical or staff block, and then the red for the case management ICU block. The yellow represents our access corridors. So this is how it plays out on the actual building. You have the medical block up, the case management at the bottom side. The yellow is a circulation path, which leads to decontamination zones. On the top right, you have the staff decon. And then on the western side, you have our emergency decon and then our patients decontamination. We also have the exits as shown with the arrows. The red arrow at the bottom right, unfortunately, is where the morgue is. And for those who might not make it or those who pass out, they will be taken through that side to the mortuary. So we have the middle belt handling the mild and moderate cases. Bottom right for the severe cases, it's quite close to the morgue. So we don't want patients to see dead people being moved away. So we plan to have all that. And then on the western side, you have the laboratory, the biosafety 2.5 laboratory. You have the patient's arrival and the patient's departure areas. On the northern side, you have the administration and then the staff areas. At our bottom left, we have the recovery gardens. And I think this falls in with our previous speaker's talk on the neuro effects of the spaces on patients. The green place we see between the healthy and the dirty area is a separation or dilution area. And it's also good to bring in fresh air and also give views to the patients. So our whole facility was zoned, and each zone requires a different set of PPEs. And this one shows which area requires which level of PPE a user of the facility must use. And also I spoke of staff and patient routes being different. This one shows us different routes for staff and patients, and also different scenarios, all in the bid to keep the virus at bay. So this shows an animation of the project. You can see the diffuse area with the trees taken out. In our corridors, we also had skylights to bring in the natural lighting. You can see our recovery gardens also just heading to the western side. So this shows how it fits in context to the existing hospital. This is the block plan of how it looks currently. So as I spoke previously, we had a lot of review sessions and consultants from the University of Ghana Medical Research Institute. They helped us with the laboratory, the biosafety laboratory. Our regular meetings doing design and construction with the whole team, consultants and the military. Yes, so for COVID-19 containment and isolation center, we'll definitely be talking about airborne disease control by HVAC systems. The research and reference material in this session is by courtesy of Atlabac Consulting, with its lead consultant being Engineer Robert Pashinsky, a member of ASHRAE. On the grounds for the design and construction, the team from the Ghana Institute of Engineers was led by Engineer Samuel Magnus Asiedu, as shown in your screen. So broadly, we adopted a negative pressure concept for our HVAC design, where patient rooms have negative pressure, or better put, lower air pressure than in the corridors. This concept is to prevent used air in the wards, which is expected to be contaminated, from getting into the corridors where healthy hospital staff would be commuting. By this, we have the pressure monitors both in the corridors and the rooms, which indicate pressure differences and will set off an alarm if negative pressure is compromised within the wards. Going one step further into the science of the HVAC design of this facility, I'll briefly talk about air change rate and dilution, relative humidity, computational fluid dynamics, that's CFD modeling. So air change rates per hour is basically the time it takes to completely replace the air in a room with new air in 1 hour. Complete change of air in a room would also mean complete dilution. Time to provide 99% dilution. So with what we have on our screen now, if an infected person enters an air-conditioned space and coughs, releasing 100 pathogens into the air, and we have 4 air changes per hour, it will take 104 minutes to clear the room of pathogens, leaving only 1. If we increase the air change per hour to 6, we reduce this time almost half, that is 69 minutes. Then when we get to 8, it doesn't change much. Then 10, also not that much from the previous. So 6 air changes per hour is pretty much the standard for dilution. Relative humidity is the amount of water vapor actually in the air, expressed as a percentage of the maximum amount of water vapor the air can hold at the same temperature. Maintaining relative humidity of a room between 40 to 60 is optimal in the containment of COVID-19. Looking at the chart on our screen, we have the health issues on the right and the activity levels in relative humidity to the left. One would realize that 30% at 30% relative humidity, the activity level of viruses dip, but from 40%, they are almost inactive. Many viruses and bacteria carried in droplets are less infectious in this range of relative humidity. Conversely, when the indoor air is dry, their ineffectiveness is even higher. When relative humidity is between 40 to 60, this is the range that optimizes the ability of the immune system to fight viral and bacterial infections. So we increase the air change rate. We want to keep within this RH range to make sure the viruses are as weak as possible. So now we go to computational fluid dynamic modeling, CFD modeling. This is used to simulate or check airflow patterns to ensure there is even distribution. In airborne infectious isolation room, we would be looking at virus transmission patterns and control. As shown in the model on the screen, we have the air coming from the top and the return or exhaust also at the top. So the airflow pattern is from the top, hits the ground, and sucked up through the return or exhaust. So in the event of an infected person standing under the supply and a healthy person under the return, contaminated air will be swept to the healthy person, even though he might be 6 feet away, observing social distancing. So it's important to understand airflow patterns in hospital environments. Typically, in most airborne infectious disease isolation rooms, you would find a return behind the bed heads so that if the patient coughs, the contaminated air is sucked right out of the room before it's inhaled by another person. More recently, it is preferred to have the vents at the bottom for optimum protection of the occupants in an air-conditioned room. Applying the same example to this scenario, an infected person coughs here, a healthy person stands there, and so applying the same scenario to this situation, The contaminated air gets sucked out at the bottom, out of range for anyone who is in the room. There's a lot more information that can be drawn from these CFD softwares. We can also ascertain calculated virus containment efficiency, probability of infection analysis, risk of infection with filtration, but these can be dealt with later by the tech experts. We also have to talk about ultraviolet rays in the treatment of COVID-19. So this radiation are those with the wavelengths between 200 and 290 nanometers. It is germicidal and also used in ultraviolet therapy and known to kill coronavirus. The virus can be filtered and disinfected to 99% efficiency with the use of UVC and MER15 filtration. These are often mercury bulbs, and their efficiency over time depend on a whole lot of factors. Here we have a few examples for its application. We have the air handler disinfection, which is the first box in your shot. And then we have the air handling unit or the rooftop unit and airstream disinfection, which is what we used at GIDC. Over here, we have the UV lights in the supply as well as in the return. So contaminated air is not sucked up into the building, and contaminated air is also not pumped into the facility's immediate environment. We have the makeup air that goes through a tube, and we also have the room surface disinfection, which is also good for rooms when they are unoccupied, because it's known to have a cancerous effect if you put them on whilst people are within the space. So on HVAC airborne disease control trends, in the past, we wait for occupancy indoor air quality complaints. Then we do air sampling and lab testing. Then HVAC assessments and recommendations are made. At present, we have the COVID-19 pandemic. We have the ASHRAE COVID-19 recommended practices. We also have the installation of COVID-19 HVAC controls. In the future, we have unknown potential hazards. We have machine learning, indoor air quality algorithms. We have smart buildings, proactively protecting occupants. So as I said earlier, we had shifts, day and night shifts during the construction of our project. We also used the 3D, EVG 3D construction systems. So for our floors, we had the in-situ reinforced concrete slab. Our roof construction was concrete filler slab with polystyrene. We also had steel sheets on timber rafters. For our walls, we used a 3D wire panel with shotcretes on both sides. Our flooring was epoxy. Measures we took for energy were insulation of the roof. We also had insulation of external walls, air conditioning with air-cooled chiller, then energy-saving bulbs, both internal and external. So our building is a green building, EDGE certified, with exemplary achievements in 23% energy savings, 28% water savings, 31% less embodied element in material. And that's some of the features with the negative air pressure within the building, one-way traffic for patients and for staff. We have antimicrobial paints on the walls and hands-free faucets and sensors for the doors. So we minimize touch. The total project cost was $7.5 million, and this includes the building structure, medical equipment, and all other running costs. So in your shot now, you have an aerial view of the project during its construction period. This is the view of the project when we finished. Now the rains have come in and it's looking more flush with the greenery and the trees we planted around it. This is a view to the entrance with the signage to the right side. So in your shot now is the nurses station and the corridors. This is a typical 6-bed ward with the appropriate spacing as recommended by our reference documents, epoxy floor, antimicrobial paint for the walls. So this is our corridor with our hygiene stations as we move on. And the corridors were also big enough so that in the event of overflow, we could even have beds in the corridor. You can also see the skylights alternating every light, also to augment the daylight and help in the psychology of our patients. This is our waiting lounge for recovered patients. Before they leave, they are brought here, tested, and then signed to leave the facility. So factors leading to the success of the project were the exigencies of the time. Also, we are very grateful to the leadership of the private sector. We had the support of the government. And also, we are grateful for the commitment of the consultants, the discipline and consistency of the military, and the benevolence of the Ghanaian people who contributed to make this a success. So in conclusion, with our emergency approach to this project, we relied on the experience of local healthcare facility designers. We also relied on inputs from health sector practitioners, that's the doctors, the lab technicians, the nurses, facilities managers. The literature and research on the subject matter was also very key, which was our tool for the numerous review sessions during design and construction stage of this project. Thank you for your attention. Bye.
Thank you, Fiifi. Wonderful presentation and very, very important presentation because everyone was commenting on it because it's technically very sound and nice. And particularly in the period of COVID, everybody has a lot of questions. And the way you have done it with first of all, the very good thing which we liked is you got a participation of various organizations in your area. That is a great support. And then your spatial and engineering requirement has been documented, and that document got transferred into architectural planning and the functional spaces, and particularly the HVAC, that is, heating, ventilation, air conditioning with the air quality. And generally in the sense we generally used to miss the, purification. We always used to do ventilation and, pressurization and also the filtration, but UV introduction of ultraviolet has got into, it is a colony of pathogen in the filter bank which is getting killed. So it is a wonderful presentation. So we have some questions already in the question box, and the first question actually it is with the, can you please enlighten us on little on hospital? This is for Tye Farrow. Tye Farrow, they says that thanks a lot for your very inspiring presentation. It is great to see that your starting point is a building health. I also find it very important to develop hospital as a neighborhood asset, integral part that all adds into a neighborhood life instead of building isolated infrastructure. Have you involved local community in all your projects, like in case of Social Medical Center? Do you have any feedback from the local resident after your projects were completed? So this is the Tye Farrow, you may answer, please.
We do, and the Seashell hospital that we designed with the Indigenous community from the west coast of Canada. The first meeting we had was the elder circle of the Indigenous community, and we started them and saying, what were we trying to achieve? What was very important? And what are the principles we should begin with? And from that, we began to evolve the design. We start with a common ground and a critical eye session. And I think the question is important because we know that a hospital has to be functional, it has to be cost effective, it has to be delivered on time. And we start with those questions and then we say, what else? And the what else was, it has to reflect the values, the aspirations of the community moving forward. And we saw a lot of examples of hospitals that was explained, that after 20 years' time are torn down. They're not beloved. They're not funky. I mean, they're limited in their time. How do we begin to create architecture for healing that enhances not only environmental health, not only personal health, mind health, as well as community health? And our buildings do speak to us. The question is, are they speaking to us the things that are important, or are they radiating something else? And so starting at the outset with the wider circle of people that are using our healthcare facilities through an active co-creation process is a foundation for creating buildings that will endure.
Thanks very much. In fact, some of the questions have been answered by the speaker in the question box itself. But I would like to know, do we have time? Or I think we are almost very close to the thing. I'll like to know from you whether we can have any more questions. Ping.
I think you can still take more questions if there are some coming in.
One is also again, can you please enlighten us little on hospital facades and if they can contribute in healing process? It is again to Tye.
Well, definitely. I think everything is tied together. I mean, we think of the facades importantly around a building performance in the sense of the energy, the environmental aspects of the building, but they are, again, important to radiate the messages of the community. I think what we're seeing today is, hospitals, a lot of them were greenfield hospitals out in the countryside or from a city. And now with retail and, moving away from the downtown areas, and so a lot of our downtowns are being gutted. And what we're beginning to see is this idea on bringing a variety of the components back into the heart of, a main street, a high street. And they're participating, and the facades specifically are beginning to radiate the values of openness, abundance, optimism, both of the organization, but also bringing the health back and radiating the concept of healthy communities, which hospitals are partners. So clearly the facade is not only the inside, but the outside, like the butterfly project that I showed. I mean, it's the facade of that, all made out of wood, is trying to radiate a message about what cancer is. It's communicating that a butterfly is both fragile, but optimistic. And those ideas are important to radiate to the people that are coming not only to be healed, the metamorphosis, from the little bug to the butterfly. Those are conscious as well as subconscious things that are mind processed. And so as a foundational thing to begin to communicate the values of hospital organizations, because a lot of our hospitals are clearly things that seem to have flown in from somewhere else in the world and landed in a community without speaking specifically to the local community.
There is one more question for Karin. Karin, of course, you answered, but it is for the interest that, most of the people like to know, because in your master planning, you have talked about grid and what is the ideal grid for a small footprint hospital, like say 10,000 square meter. So you can, though you have answered, but I would like to answer it in person because this is a very interesting question, and please go ahead.
The question is often asked, and I think it's depending on whether it's a hospital including these high-tech floors where you have operational theaters, MRT, CTs, these big machines where you have to include those, because that's much easier if you have a grid that is big enough. And the optimum grid in Switzerland is in between 7.8 and 8.4 meters, I'd say. And that's always, and we try to find a grid. I mean, the facade then can be maybe a little bit freer also in the form, but in the grid itself, we try to be very consequent. It should be bi-directional, so you can change the direction of the floor plan usage as well. And then it's a multiple of 1.3 or 2.6 meters, so you have good sizes to include doors. For example, hospital doors are quite large. If you want to go through with a bed, you can integrate offices, you can easily integrate consultation rooms, and that's quite reasonable grid. 8.4 means also big pillars, that's true, and that is always a constraint if you then have to build your light walls in between it. So it's a compromise in between construction and the optimum grid. But I think in between those, I would recommend to build.
And what are you finding floor to floor height? I think that's the other key piece that seems to make the buildings redundant.
Exactly, yes. We had a big problem in Bern. The master plan I was showing, it's the hardest part is because we have these old buildings to integrate within the new building in this time until it gets reused completely. And I mean, we will always have to learn. But for the moment, we suggest 4.5 meters for this highly installed floors, because then you have enough space. You need more than a meter or above, yeah, a little bit more than a meter, or 1 meter would be necessary for all the ducts leading to the rooms with ventilation and electricity, and it's full, it's extremely full. And for the floors on top of it, so, or beyond, well, it mustn't be constructed piled on each other, it can also be in other ways, but the levels for care units or office buildings, when you want to be able to transform them, office buildings could maybe also be less high, but then we use 3.5 in Switzerland. I don't know, Tye, or Fiifi, whether you use other heights there, but that's what we recommend there also for the installations.
But for this large span, we have seen that pre-engineered building works, much faster and better in our places. We have seen that is what. How is the practice in your place? Is it pre-engineered steel structures are also followed, or it is only the pure concrete RCC walls, etc.?
Was that for me?
Karin, Karin.
I didn't really understand the question. I'm sorry.
See, when you're talking about the larger span, 8.4 meter, etc., then we are following the pre-engineered building, that is steel structure. Are these practices are also in your part of the country?
Yeah, well, we have concrete structures in most of the buildings, I would say, for the moment. I think also Christoph would say the same for Baden, for the project over there. They've also done it in concrete. So it's a mix of steel and concrete, of course, and it's not prefabricated then. But of course, that's also a possibility. And I think if you work with wood, you are fabricating it.
One last question for our Fiifi. How can similar airflow to be achieved in every corner or floor for hospital, especially in crowded areas through architecture?
Okay, I think first of all, it depends on the mass of the hospital. As you can see from our design, we break the spaces down and we make sure we have the courtyards or air pockets within the space. We don't have deep rooms. So if we're able to, it's first about the massing of the hospital before the details come in. So you don't have 2 deep rooms, and so you can have some lighting. We're also very mindful of the psychology of patients in the spaces. It played a major role in what we did in our emergency project, but there's another presentation that can bring that up. But then if you have a good HVAC and mechanical engineering, they have the softwares as I presented. Yes, they can use that to test the model and make sure that each room has the appropriate HVAC system installed over there. And also we break the building up into thinner spaces so we can have the ingress of light and compartmentalize it. So in case you have to do any sort of maintenance on the hospital, you don't have to shut down the ventilation system for the whole facility. You make it in smaller compartments, because maintenance is a normal part of running hospitals. So basically 2 things: the mass must not be too deep, and also the HVAC design. Yeah.
Thank you. Now, I think we can be in the closing remark. What I could say that we had wonderful presentation for all 4 of us, like right from Christoph, he elaborated right from the 18th, 19th century onwards and how the present design and the historic overview of the whole thing, and also talked about the spine layout, the radial typology, etc. And similarly, the very great part of Tye Farrow was the human performance of the building. And it is really very important that, such aspects are also being taken, in a special note. And Karin, of course, yes, quality, quantity and cost are the drivers, which are, it's a buzzword, absolutely. And master plan leads to open heart surgery. I will never forget this part, that this is one of the greatest thing. And Fiifi, you touched the wonderful part that is very technical and Lot of people have given in the chat box the comment about your presentation because it was very, very important. Lot of people have a lot of enthusiasm. See, the pandemics are not just gone. It is still, people are preparing ourselves in all the way. So with this, I think I'm just handing over to our Secretary General to make those announcements of our future next webinar of the World Architecture Day, etc. Over to Peng Yin.
Yeah, thank you. So on behalf of the UIA, I would like to register our greatest appreciation to the moderator and all the presenters for your valuable contribution towards this very important topic, which is most timely and appropriate, especially with the pandemic, which is still affecting many parts of the world. We must also thank the UIA Public Health Group under the capable leadership of the Director, Ray Pentecost, assisted by Shipeng Lu, and also two very passionate members, Nuwina Muhammad Nawawi and Fani Wabili, who have put in tremendous effort in organizing this webinar, and the support given by the UIA Secretariat in making this webinar a success. I would also like to thank all the participants for taking valuable time off in joining us, and I hope the presentations have inspired you to drive for Design for Health. And before we end today's event, I would like to announce that the third series of the Design for Health webinar will be held in conjunction with the UIA World Architecture Day 2022. The UIA World Architecture Day was created by the UIA since 1985 and is celebrated annually on the first Monday of October in parallel with the UN World Habitat Day. And this year, it will fall on the 3rd of October 2022 with the theme Architecture for Well-Being. We are in the midst of finalizing all the speakers, and we encourage all of you to save the date, and we look forward to your participation. We also hope that all of you will join us in our efforts in actively promote and support the values and the principles of Design for Health, and together we can make a meaningful difference. And thank you.
Thank you.